Welcome to the Thunderbolts.info podcast for December 19th, 2016. Over the last 2 years or so in the Thunderbolts Project's YouTube channel, the question of the origins and the nature of comets has been front and center in our video productions. In 2014, the European Space Agency successfully landed its Rosetta probe on the nucleus of Comet 67P, and this was an opportunity to test the predictions of the standard theory of comets, which for more than half a century has described comets as so-called dirty snowballs. As you know, if you have followed our space news coverage, the comet did not ever cooperate with the investigators' expectations. Well, believe it or not, even though the vast majority of the general public still is not familiar with the electric universe, the electrical theory of comets is not entirely new. In fact, it didn't even originate in the 20th century. Today, we're going to be talking with a guest who has done some remarkable historical research into the origins and the evolution of the electrical concepts of comets, actually going back hundreds of years. Our guest is Täger, and his investigation has not only revealed remarkable facts on the origins of the electric comet theory, but it may offer some real insight into the history and the culture of science, and the question of why certain scientific theories gain official acceptance over time, while others do not. Hannes, welcome to the program.
Hello, Michael.
Now, I actually learned about your research from our friend Eugene Bagashov, who recommended you to me as a guest, and I believe that Eugene met you at the most recent Thunderbolts conference, EU 2016. So why don't you tell us a little bit about your experience at EU 2016 and what it was that first led you to take an interest in the electric universe?
Oh, I had a great experience with the EU 2016. I met Yuri or Eugene Bagashov, and I had the first time the opportunity to meet all the other translators and proponents of the electric universe theory. In fact, I'm an economist, but I was always interested in aviation and space flight since my childhood. In 2012, I found a German website with great information about plasma cosmology. This website is called Plasma Universum and is maintained by Laville-sur-Illon. And this sparked my interest. I searched for more information and discovered the website of the Thunderbolts project and the electric universe theory. I was so fascinated by the opportunity to contribute something to this revolutionary project that I joined as a volunteer and translator. And in June of 2016, I had the great opportunity. In the outbreak room of the conference, I gave a little talk called The Introduction to the History of Electric Comet Theories. Later, I was encouraged by Eugene Bagashov to provide this material to the Thunderbolts. And so I started to create a PDF book about the history of electric comet theories. And I'm just trying to give some information about my findings in this interview with you.
Very good. Now, one of the reasons I was interested to hear about your research is because I think it's helpful to understand the historic evolution of competing scientific theories over time. And I think it's telling that even hundreds of years ago, the electrical properties of comets seemed apparent to a number of different investigators. So why don't you begin by telling us about your findings? And the first question I'd like to ask is, did you encounter any surprises in your research?
Oh, I did in fact experience a lot of surprises. I was completely surprised when I realized the sheer number of researchers with ideas or theories of electric comets. I discovered 50, 60, 70 proponents of the electric comet, and I think there could exist some more. Furthermore, I was surprised about the open-mindedness and brilliance of all these people. Not everybody was a physicist or astronomer. Many had a great number and diversity of jobs and interests, and their migrated and continued their work in other countries. I found Scots and Irishmen, Englishmen and Canadians, Australians and US Americans, Germans, Austrians, Italians and Frenchmen, Norwegians and Swedish, and even scientists from the Swiss, but also from Russia and Tajikistan. So you can see it was not only a limited idea to some advanced countries. However, another fact was the biggest surprise to me. I had expected that scientists could come up early with the idea of electricity if they observed heads and tails of the comets. But then I noticed there were two groups of scientists. One group explained only certain features of comets with the help of electricity. But a second group of researchers wrote about an electric sun, electric planetary system, and even about an electric cosmos or universe. And this was really surprising.
Well, so that kind of discovery certainly is broadening your investigation and making it even more significant. So, what would you say was the oldest, the earliest example you could find of someone proposing an electric comet theory?
Yes, it is about 250 years. I repeat, it is about 250 years old,
Wow.
according to our current state of knowledge. And it seems the development of electric comet theories had a first early peak in the late 18th century. Then, in the late 19th century, the electric comet theories gained ground. They made it into the books and lexicons, and some experiments were thought to prove the electric nature of comets.
Okay, so why were investigators as early as the 18th century already starting to take an interest in the electrical properties of comets?
There was a general excitement about the fascinating but also frightening power of the electricity among scientists and laymen. Electrical experiments, for example, by Gray with his so-called flying boy, by Franklin with his flying kite, and by Lichtenberg with his discharge patterns, amazed and perplexed people. The death of the experimental Professor Richmann in St. Petersburg in 1753, caused by a lightning strike, was glorified by his peers and colleagues. Now, many researchers try to explain all unresolved issues with the help of electric currents and discharges. Everything was electric.
Hmm.
At the same time, the observation instruments of astronomers were improved year by year. Some astrophysicists speculated that auroras and zodiacal light could be electric in nature. So the next step was the comparison of both phenomena with the tails of comets. Hence, the light of comets and comet tails were assumed to be electric phenomena as well. One popular book claimed there are two types of comet theories, electric theories and others. And remember, we are still in the 18th century.
Well, could you give some specific names of the earliest pioneers of the electric comet theory?
Early pioneers of electric comet ideas were Hugh Hamilton, Andrew Oliver Jr., and the French Comte de Lacépède. In 1767, Hamilton published his work Observations and Conjectures on the Nature of the Aurora Borealis and the Tails of Comets. Aforementioned Andrew Oliver Jr. became famous for his groundbreaking work Essay on Comets in 1772. And the Comte de Lacépède, with a long French name, I hope I get it right, Bernard Germain Etienne de Laville-sur-Illon, wrote some papers about electricity in the 1770s and published a book about the theory of comets in 1784. We should also mention the German physicist Ernst Chladni. He did not research comets, but After a discussion with his famous mentor, Georg Christoph Lichtenberg, he was inspired to create a theory of meteorites. Electricity played a key role in this description of the light of meteorites. And this theory from 1794 became accepted after many years of discussion and was probably helpful for the work of proponents of electric comets. Finally, it's exciting to read that a German doctor, Carl Gottlob Kühn, discussed the following phenomena as completely or at least partially caused by electricity: thunder, lightning, thunderclouds, St. Elmo's fire, summer lightning, the atmosphere, fireballs, aurora borealis, comets' tails, waterspouts, hurricanes or tempests, rain, fog, hail, earthquakes caused by subsurface lightning, volcanic eruptions caused by electric sparks, and even connections between two volcanoes. Also, the influence of electricity on vegetation and animals was discussed, but the most attention was focused on the treatment of humans with electricity in this time.
Wow, it's amazing hearing about this research that's over 200 years old, and this sounds like a person who would be right at home with the Thunderbolts project and a lot of the concepts that we're talking about today. So why don't we discuss now how electric comet theory continued to evolve moving on into the 19th century?
Yeah, today's official history writing is often mentioning the names and merits of famous astronomers like Johann Hieronymus Schröter, Wilhelm Olbers, Wilhelm Bessel, and Sir John Herschel. They continued the development of theories of comets, had electrical explanations, especially for the comet's tails, and the Russian Fyodor Bredikhin put all in a mathematical model. However, there are other forgotten scientists who deserve our full attention. For example, Haberle and Gruithuisen. Both Germans underlined the great role of the electrochemistry in the years 1810 and 1811. In Haberle's opinion, God had created the millions of cosmical balls in the ether with the help of electrochemistry. And Franz von Paula Gruithuisen assumed the most diverse chemical and dynamical processes in the comet's tail. He underlined the importance of electromagnetic variations and effects and the electrochemistry of comets. And we have Thomas Mackintosh, a radical socialist and inventor. He published The Electrical Theory of the Universe in 1835 and 1836. In this work, Mackintosh also described cometary bodies and assumed that the Sun and comets are both highly charged with positive electricity. And already in 1832, the philosopher von Eschenmayer came very close to the plasma double layer when he claimed that a layer exists that is separating regions of positive and negative charges in comets. Some decades later, John Allen Brown was the first who applied the experimental results of the behavior of ionized gases in discharge tubes to space physics. And this opened another gateway for electric comet theories.
Well, I'm curious hearing about all of this innovative research and the kind of hypotheses that were being proposed. What were the competing theories at the time? And how did the proponents of those other theories react to the electric comet theories?
Yes, it was a real challenge. At first, let me make some remarks about existing theories. There were many. In 1828, a prize-winning essay on comets in England discussed different comet theories. There were many different theories for the nucleus, the envelope, the tails, and the light of the comets. There are too many to name them all, but let us take a look on the theories about the tail. One scientist thought the rays of light streaming from the sun are able to force the envelope of the comet into the shape of the tail. Another theory assumes the tails are formed by the sun's attraction alone. A third party claimed an unknown force of repulsion to be acting, and others assumed the existence of a dense atmosphere about the sun in which the rarer medium of comet strives to rise up, like smoke in the Earth's atmosphere. Later in the 1870s, another publication quoted, beside Newton's old theory, modern conventional theories by Lehmann, Tyndall, and Täger. Lehmann tried to explain the shape of the comet's tail with the different strengths of gravitation and believed in a low tide and high tide of the comet's atmosphere. John Tyndall explained the tail of comets as a result of chemical effects of sun rays on a static ether. And Wilhelm Täger stated comets would be snowballs, ice balls, or showers of ice. As we know, this idea was recycled 78 years later with the famous dirty snowball model. Let us use an example from 1871. The German physicist Friedrich Zöllner had just published a challenging book about the nature of comets. And he thought the sun was a huge cathode, and the vapors developed from the comet, which consist of very small particles, yield to the action of the free electricity of the sun. And the two German scientific main magazines or journals in the field of astronomy did not react to this book for several years. No review was written in this period. However, his peers and colleagues reacted immediately, and an intense scientific discussion started. In 1872, the well-known Professor Budde published a complete book with critical remarks about Zöllner's cosmological ideas. He called the new theory simple and elegant, but added that the current form of this theory would still include many problems. Also, the aforementioned Professor Täger discussed Zöllner's work in his own book about comets. However, Täger underlines the snowy or icy condition of comets. It is noteworthy that both opponents who refused the electric comet model by Zöllner considered frictional electricity on the sun as an opportunity. And Zenger's major argument against Zöllner was the belief in the electrical balance of all celestial bodies, suns, planets, and comets alike. A permanent exchange of electric charges should keep them neutral.
So moving forward in time now, do you have any thoughts as to why the popularity of electric comet theories appeared to reach its peak sometime in the late 19th century?
This time was a time of extremely fast technological, technical, experimental, and theoretical progress. Astrophysics and astronomy got access to bigger telescopes and devices for photography, photometry, and spectral analysis. Furthermore, experiments in discharge tubes allowed to enter completely new ways of research. And many results of the use of the new equipment indicated and supported electrical explanations of comet features. The new tools were used by scientists like Reynolds, Proctor, Zöllner, Solon, Berthelot, Germain, Ennis, Wiedemann, Hasselberg, Förster, Goldstein, and many others. And all the mentioned researchers promoted the electric comet idea.
Very good. So as we move into the 20th century and we're looking at how the scientific investigations into comets evolved, what are your thoughts as to why the electric comet hypotheses eventually fell out of favor among mainstream scientists?
I think the decline of the influence of electric comet theories had a number of reasons. So the success of Arrhenius' theory of the ray pressure of the Sun seemed to explain some of the comet's tail's phenomena and reduce the general interest in other explanations. That is strange because Arrhenius himself advocated the electric comet. Also in science, fashions and trends are existing, and without the opportunity to check the electrical features of the comets on the spot, electrical explanations lost its trendy character, and scientists turned their attention to other solutions. And there was not enough knowledge about plasma. Even the term plasma was not coined before the year 1928. Later, plasma physics existed and worked always in the shadow of atomic physics. And finally, World War I and its ramifications and a growing narrow-mindedness of scientific institutions and scientists could be responsible for this development as well.
Right. Well, here at the Thunderbolts Project, we're representing the idea of electric comets once again in the 21st century. And our chief science advisor, Wal Thornhill, kind of took up the mantle, and he first wrote about electric comets in the early 1970s. But I'm wondering how ultimately the idea of electric comets was reborn, and who do you think perhaps most contributed to this rebirth?
I think the idea of electric comets was never dead, but it was in a kind of sleep or stasis over decades. Also, Immanuel Velikovsky, highly interesting exchange of letters with Einstein, with a discussion of electromagnetism, including also the electric phenomena of comets, did not change the situation. Especially the later condemnation Velikovsky's as a pseudoscientist hampered new reflections about the electrical nature of comets. However, I think Velikovsky's effort was not wasted. Ralph Jürgens and Earl Milton discussed the idea of an electric sun that implied electrically discharging comets in the 1970s. In the early 1980s, James McKenney published a plasma discharge comet model with the assumption of growing comets. While Thornhill, however, continued Jürgens and Milton's path with a dissolving comet because of plasma discharges. And more recent developments include, for example, Subron Ibadov's discussion of possible mechanisms of cometary outbursts and contributions about the electrochemistry of comets by Franklin Anariba. And I think the number of researchers who deal with electrical ideas will rapidly grow in the next years.